So now we will find that this percentage for 0% or 2% or 10% or 50%. Okay, that means that at 10% it is the reference or the reference number for MTF calculation. At 10%, okay, you will find that line pairs per centimeter is 12 12 line pair per centimeters. Okay, so if I want to check the resolution of the machine, I have to check this number 10%. 10% for any CT machines, I have to check this number for 10%. If I go here for help and for MTF calculations, MTF, okay, here you will find that at 10% is 3.6 line pairs per centimeters. Okay, that's 4, and 50%, sorry, for 10% is 6 line pairs per centimeters. Okay, and for 50%, 3.6 line pairs per centimeters. Okay, so our machine, this is the reference for us. If the values of CT machine in this range, so it's accepted for me. If the line pairs is greater than 6, okay, so that's okay. That means that that the machine can differentiate between greater number of line pairs per centimeters, so that's good. So if we coming back again to our IQ analysis, you will find that here that 10% is 12, so it is greater than 6 line pairs per centimeter. That means that our machine is good. Okay, at 50% here for help, 3.6 line pairs per centimeters, but our machine is 6.9 line pairs per centimeter, so that means good. Okay, so the reference for me is the manufacturer or NEMA protocols. Okay, here 6 line pairs per centimeter at 10% and 3.6 line pair per centimeters at 50%. That means that my machine is working properly and everything is okay. So it's very important test, okay, for MTF resolution. Okay, that's for MTF. That's for noise and CT number and homogeneity, and for slice thickness as I explained before. Okay, now if I want to measure, if I want to make measurements for CT number or CT accuracy or uniformity or noise using manual method, manually we can use it. Okay, we will select here MBR. So now it is easy for anyone to do this measurement manually. Okay, how can I do that? Open it for 2D image. Okay, again, okay, this is the water phantom image. Okay, I want to measure now. CT number or CT accuracy and noise and homogeneity. Okay, how can I do that? Measure. I will select. I will draw the ROI. Okay. Okay. There is a lot of methods. Okay. There is a lot of methods. Okay, we can use one ROI only in the center of the image like that, and to check the average, which is mean the accuracy, the average value. Okay, the accuracy, and using standard deviation value, which mean noise, and maximum and minimum values, which will be used in uniformity calculation, but the more accurate method, okay, not this method, you have to delete this one and to draw ROI, 5 ROI. Okay. Okay, this one at the top and bottom, make copy. Okay, 5 rows be here, and another one the same size, and another one in the bottom, and in the center here. Okay, destroy. Okay, okay, so I will select CU all measurements. Okay, 5 rows, one at the top, one at the bottom, on the right side, left side, and one in the middle. Okay, so now that's for accurate measurements. That's for accurate measurements. Now I have 5 values for average, for CT number, for CT accuracy. Okay, and I have standard deviation 5 values. Okay, here, and maximum and minimum 5 values. Okay, using these measurements, using these values, we can measure. Using these measurements, we can measure CT number. So at first, I want to measure CT number or CT accuracy. Okay, I have 5 rows. 5 row, number 1, number 2, number 3, number 4, number 5. Okay, for first one the value was -2, second one -2, third one -3, fourth -2, last one is 0. Okay, so taking average for all these value. Okay, average. Okay, after that will give you the CT number value. When I calculate the summation of all this value, okay, divided by the number, okay, okay, -2, -3, -2 divided by 5. Okay, it will give us the value of CT number, which is 549 divided by 5, which will be
-1.8.
minus
1.8.
minus 1.8. Okay, this is the average value or the accuracy, CT number of accuracy of water. Okay, so you will find that this number is in the accepted range or not in accepted range. Okay, this is the first one. That's for CT number or CT accuracy. Okay, second, if I want to measure CT image noise, using the value for ROI number 1, ROI number 2, and ROI number 3, and ROI number 4 and 5, okay, standard deviation value, which represents the noise of image. Standard deviation represents the statistical noise. Standard deviation value here is 0.83, okay, plus 2.65 plus 2.83 plus 2.65 plus 2.83. All these values divided by 5 will give us CT image noise. Okay,